Hello everyone. First of all, I would like to extend my warm welcome to all visiting guests to NIWA. 大家好，非常欢迎大家来到 NIWA 做学术交流。My name is Dong based in Christchurch, South Island. Here I would like to give you a short presentation on what is my work in air quality group in NIWA. As this title suggested, my work is to develop land use regression models as a tool to investigate a range of potential air pollution problems. In this presentation, I just want to demonstrate land use regression models' pollutant mapping capability. That is to simulate the pollutant spatial variation, particularly in urban area. Okay. Like many metropolitan areas in the world, cities in New Zealand is not immune to air pollutions. Air pollutions here can be sourced from industry, domestic fouls, as well as vehicle emissions. This work I will only focus on traffic-related pollutions. Okay, as you can see here, the vehicles numbers in New Zealand on the road generally increase with time. Well, not too much. Increased exposure to traffic-related air pollutants is known to be linked with adverse health effects, as I show in this picture. Here I would take the pollutant nitrogen dioxide as an example and map its spatial variation across Auckland City based on limited observations of nitrogen dioxide from the monitoring network. So basically, we want to know what is nitrogen dioxide level for unsampled area, like here. Well, there are many ways to do this, like exposure indicator variables, interpolations, dispersion models. But here we only take land use regression models approach. Having said that, there are many research questions we can address by using land use regression models. But we only want to demonstrate that the capability of land use regression models to simulate the spatial variations for annual level of nitrogen dioxide. Okay, so what is land use regression models? So land use regression models are trying to build statistical relationships between land use variables and pollutant levels. Land use variables here could be traffic activities, green and commercial space, etc. We built land use regression models to Auckland City. Visually speaking, the simulated variations generally conform to the ground truth. For example, the elevated level of nitrogen dioxide in Auckland CBD near Ponsonby area, which is quite near to your current locations. We built land use regression models with nonlinear boosted regression trees instead of traditional linear models, which leads to better predictive performance in terms of R-square and the root mean square error. Okay, this slide shows you the land use variables included for building this model. Finally, I would like to mention a little bit about land use regression models. Land use regression models has its strengths. That includes to capture small-scale variability of pollutant level in space. However, it lacks the capability to connect specific source of emissions to pollutant concentrations. Thanks. That's all from me.